Everyone, here I'm Vadil Sagar, and let's go for the part number 14 of the present chapter 1 of standard 12, electric charge and field. So, okay, in the part number 13 we seen our regarding the Gauss law, and as I said you in part number 13, it is a very important for the exam point of view as well as for the competitive exams examples and its significance point of view also. So you should very clear about the Gauss law, and today we will go for some examples regarding the Gauss law, so it will be better understanding gives you. Okay, let's start with the 11 number example. In the particular this example, we have one Gaussian surface. If you are not completing your part number 13, you cannot go into part number 14. Please go below. I am mentioning the link for the part number 13. You should be complete the Gauss law very clear, then you can go for the part number 14. It means this one. The electric field component in a figure number 27, there is a x component of electric field, y component of electric field, and z component, but that the EY and EZ, it means electric component in the respective Y and Z axis are not there. The only electric field applied on this Gaussian surface, it means particular cube, we are applying the electric field in this direction, in this direction, which is alpha time x raised to 1 by 2. It means A alpha under root x, where alpha is equal to 800 x raised to 1 by 2. Now what we have to find? A task, total flux through the cube we have to find. B point, charge within the cube we have to find. Assume our A is equal to 0.1 meter. What is A? I am not mentioning yet. This cube you have, whose side is the made up of A, it means whose length is A, and which is 0.1 meter, it means 10 centimeter. Let me clear one more thing, which is this side of the cube, it is far from the observation point, it is also A. So from this point to this point is also A, so this will be the 2A. So this distance, this side distance from this observation point, it is A. This side distance from this point will be 2A. So this will be helpful at some calculations. So let's go for the finding the total flux. That flux equations we already seen in the earlier discussions. Now here for the more detailed study of this, since the electric field has only in x direction, so your phase which is perpendicular to the x-axis, so see, electric field is this. Now this is the one phase. Suppose in a cube, I am explaining this example in a very simple language. Any cube you have, there is a 6 phase. Let me take this list. 6 phase is 1, this is 2, this is 3, this is 4, and then back one and then front one. It is means 4, 5th and 6. This is a 6 phases are there. If I am considering this topmost phase, this surface element of the topmost phase is upward direction. Now as a 12th standard student, and then as per my students point of view, that the surface component where it is, you should aware, because this is a one surface. Okay, if mobile phone screen is your surface, then the surface element of the vector surface area, it is towards the up direction. It is called outward to your mobile screen. So this is one surface and this is outward. So this is your surface element, this is your electric field component, as I said you in the x direction. So this makes a 90 degree and the cos 90 is 0. So this is not contributing. As for this also, and this front also, back also, only the flux will be there in a respective this and this. How? Because this surface has surface element is outward side, this direction, electric field is also there. So they make a, this already be seen where in a part number 13 as a cylindrical point of view. Here we have one cube, there is no matter, so that E and delta S makes an angle 0, and in the particular this surface element, surface vector in this electric field is this direction, so this makes a 180 angle. Is it clear? If you have any kind of confusions in the explanations of the vector point of view, you can call me, you can comment on the particular descriptions, Okay, I will give at the end number of my contact. Okay, so as we seen x component only there. For the faces those who are x direction perpendicular, the angle makes E and delta S is either plus pi by 2 or minus pi by 2. It is nothing but the 90. Therefore the 5 is E dot delta S. This is the by definition. You have to go for the part number 8 for this particular flux scenario. Separately going to be 0, because this is the, if you solve this vector, it is E dot delta S going to be E delta S cos theta. That cos theta is mattering there. The theta is plus or minus pi by 2. It means 90, cos 90 is 0. So this is flux will be not there. For this and front and back surfaces will not contributing in the total flux of the system of the cube. Okay, now each faces of the cube except two shaded part which you can able to see in the figure. Now the magnitude of its, let us find. Now the electric field in the left corner, which is particularly this one, left side of it, so the alpha x raised to 1 by 2, it's by default in the question it is given, and where x is the separated, as I know, this surface is the far from the distance is a, as I mentioned here. Okay, so your x is replaced by the now a, so the el is equal to alpha time a raised to 1 by 2, where alpha is equal to 800 something units are given, where x is equal to a for the left surface, and the particularly for the right surface, as I mentioned you, this is a 2a distance far away, so your x is replaced by now onwards 2a. So the new equations for the ER, it means electric field on the right hand side, alpha time 2a raised to 1 by 2. Okay, so this is a particularly electric field on the left electric field on the left side and right side. Let us combine them. Okay, phi on the flux on the left side, it is a EL time else. As we know, E dot delta S is the nothing but the flux. What is EL? You can put delta S is equal to EL into NL. NL is a respective vector of its. There is no matter. If you ignore this step, you can directly write this as we know from the our knowledge. EL is it is a bold form. Delta S is also bold. It is both are vector. If you are writing in your notebook, you can make a vector sign, please. And if you reduce your vector dot product, it becomes in a cos. So EL time delta S cos theta, where theta is equal to, for the left component, for the left surface, the surface vector is this, electric vector is in this direction, and a surface in this direction. So this they makes an 180 angle. So this is our theta. Theta will be 180. Theta will be 180, and the cos 180 is minus 1, and minus 1 contributing this minus sign, and EL time delta S. So the flux on the left hand side is nothing but the minus EL time delta S. You can put the respective EL values in this also. Otherwise, at the end we will put for the our simpleness. Okay, now go for the and delta S point of view. What is the surface element? If you have a small one, then the surface of the total surface of this left face is the square. So this is A, this is also A, so this is A by A multiplied by A is nothing but the A square. So this is the flux on the left side is minus EL time A square. Now the same phi r is equal to ER time delta S. Again it will be reduces to the your cos theta they makes an angle. Again I am explaining you, so you will not get any confusion. So this particular surface vector in this direction, electric field is also in this direction, they makes an angle 0. There is no angle between its, the cos 0 1, so directly it is a ER time delta S cos theta is equal to 0. So that delta S is reduces to A square. How it will be, you know now onwards, ER is equal to A square. So now you know the flux from the left hand side, flux from the right hand side. Let them combine to each others, and then this is a phi r plus phi L. So ER A square minus EL A square. So this is plus, this is minus, this is plus, this is minus. This I am putting here, this I am putting here by the phi r and ll. Now just I am the common out the a square, and er minus al is equal to, now I am putting the respective values of it. As you know, a square, one more the intermediate step you have to do, a square is equal to er is what, as you know from this side, er is equal to alpha time 2a raised to 1 by 2. Put the alpha time 2a raised to 1 by 2. What is el? Alpha time a raised to 1 by 2. Put the alpha time a raised to 1 by 2. Again both terms having alpha, so alpha is also going to be common out from the outcomes outside of the equations. So alpha a square, square bracket 2a raised to 1 by 2 minus a raised to 1 by 2. Is it able to understandable? Okay, if any kind of confusion you have, you can make comment and make it clear. Now just again a raised to 1 by 2 common out, so the a square is already there and square 1 by 2 common out, so 2 plus 1 by 2, it will be the 5 by 2. This is as a math student, as a 12th standard student, I cannot go in that much detail, otherwise I cannot complete the syllabus. Alpha a raised to 5 by 2, and then as you can able to see, the left part on this square bracket is nothing but the under root of, this is 1 by 2, it is nothing but the under root of 2 minus nothing is left here, so it is a 1. Okay, so now alpha is equal to 800, then a is equal to 0.1 meter raised to 5 by 2 under root 2 minus 1. Just make it in your calculator, you will get the one answer. The unit will be the reflecting by the only by the alpha unit, so alpha of those unit. And also this is a flux unit, it means flux, it is nothing but the e time delta s. What is the electric field unit? Electric field unit is nothing but the Newton per coulomb, and this is a delta s is the unit is the meter square, so the Newton meter square into the coulomb or coulomb inverse, otherwise divide by the c coulomb. This is nothing but the, no need to mug, you can also derive. Okay, so this is the first task we completed. Let us go for the second task, which is the second task if I am reminding you. Okay, so the B task is the task within the cube. How much charge within the cube, because the flux is generating this much. If once you know flux, then you can able to judge the how much charge it can be. Okay, so using the Gauss law, phi is equal to q by epsilon 0. This is the end of the story of the Gauss law in the part number 13. I am making the link of the part number 13 in the below descriptions. Q by, so the q will be here and this epsilon 0 on the front side, it will be multiplied, so the q is equal to phi time epsilon 0. Once you know phi, once you know epsilon 0, put them, the values are there, and then you will be able to find the charge also. As we know that we got an answer of the 1.05 flux, 8.845 on the 10 to the power minus 12 coulomb is the answer, is equal to 9.27 into 10 to the power minus 12 coulomb. That much charge can be inside the cube. Okay, now let us go for the 12 part example number 12. It is a little bit complex in the sense of question point of view, but there, if it is for the understanding and the examples, actually I have one student's point of view, one scenario. Actually the students are always getting fear once they have in a front of the example. That fear you have to remove, please, because examples, once you understand examples, that will not difficult for you. Generally what happen, once you read the questions and you are just getting fear, that should be not there, because once you trying to understand what they ask, what is given and what I know, then you start to calculate. Okay, so in this example also, when I am see from the upside, oh, it's I getting idea, it is a little bit tougher example. But once I start to explaining or the read this, I am getting, oh, it is a very simplest kind of example which we did in this Gauss problem, Gauss law in part number 13. So let us start. Don't regret anything. An electric field is uniform, and then positive x direction of the positive x in the uniform form from the small magnitude, but in the negative x in the for the negative x. It is a very confusing. That's why what I say, the question is very confusing. There's a one cylinder. From the center, this is positive x, this is center is negative x, that is they are saying. And this E in this direction, particular positive x direction, because the 200 I cap, and I is the corresponding to the x direction, that you know. So the electric field is given again, and x is positive from that side. If also electric field is present from the negative side also, that is minus 200 and I cap, so that it will be also in x direction. A right circular cylinder of the length of 20, it means from this to this is the 20 centimeter. Okay, and the radius of its from the center is a 5 centimeters. So radius is only 5 centimeter of the origin, it's and along the x-axis, so that the one phase in the x direction for the positive 10, and along the one of the direction the negative 10. So what is the net outward flux? A task we have to do. What we have to flux through the side of the cylinder, so the how much flux from the sides only there. And C task is the net outward flux, it is particularly from the side, from the cylindrical part, from the total, that is the C task. And what is the net charge inside the cylinder, so that at the end also we have to find what is the total charge which is inside the cylinder. Okay, let us start. This is a very simple, I am explaining you, don't worry. Actually, if you are very focused in the part number 13, once at the end of the story we completely solve our problem regarding the cylindrical problem. Once you have if you have solved the cylindrical problem, that exactly understanding what you have at that time, this you can applicable here. Let us start. A task. What is the net outward flux through flat surface? It means that is a cylindrical surface. We can see that the figure from the left face E, delta S is the parallel. So therefore outward flux is from the left hand side E time delta S, where E is equal to minus 200 and I into delta S, where how it will be the plus C, that your I cap is negative, and then surface C, I cap is vector and delta S is vector, and if you are reduces, then I is the negative direction, it is a negative direction, so that is your becomes plus 200. Otherwise, in a other sense, I dot delta S, it means I time delta S into cos theta, and those two makes an angle is equal to 180. I is this obviously, because we are indicating the minus sign, so there is a I is professionally in this one. Okay, and the surface element in this direction, as we know the surface I cap in this direction, surface element this direction, they makes an angle 180, and they make an 180, that is a cos 180 is minus 1, and then minus is already present, so it will becomes plus. So the flux from the left hand side, earlier it was negative because the electric field only in this direction, but here also this and this also present, so that's why it will be becomes positive delta S. Okay, because the reason is given, I into delta S is equal to minus delta S. Why? Because I time delta S cos theta, and cos theta is 180, 200. Now I am putting the delta S is equal to how much? This is the particular circle, so pi r square. What is the radius? 5 centimeters. So this is meter is equal to 0.05 square. So this is the pi r square. If you are reducing your calculator, you will get the positive 1.57 into Newton meter square into Coulomb. This is a flux unit. On the right hand side, particularly calculation, you can repeat it. That is a 200 plus only 200 pi r square. All the numbers are same for the calculation, so it will be the plus 1.5 Newton. So think about it. What is the difference what we seen in the part number 13 and what here we have? Their electric field only in this direction. Here in this direction, here we have in this direction electric field also. So the field flux, whatever the pass through this left hand side is not and cancel out this flux. So it will be not going to be zero in the overall flux. So this will be the also positive 1.5, and this also going to be 1.5 flux will comes into pictures. Let us go for the part number B. What is the flux through the sides of the cylinders? For the any point of the side of the cylinder, E is the perpendicular to the delta S Hence, the E dot delta S therefore is going to be 0. Therefore, the flux out from the sides of the cylinder is 0. Now, side in the sense of you can make a શું કહેવાય કે સિલિન્ડરને ઊભું મૂકો then તમારી સાઈડ કઈ થઈ પેલું તો ટોપ સાઈડ અને બોટમ સાઈડ ઇટ મીન્સ અપર એન્ડ લોઅર સાઈડ those are circles but the side it means what is called side it means this cylindrical part what I am trying to explain you. Okay, that is your cylindrical side, this one, and the electric field are whatever present in this direction, either this or either this. There is no electric field in this scenario, so electric field either this or this I can make an angle, but the particularly this surface, then the surface element is the perpendicular to it, and the delta S and E makes an angle is 190 as you can see here. Then this is going to be 0, all we know. Okay, so this is a particular for the B task point of view, answer is 0. This is very easy, understand. What is C task? What is the net outward? It means from the circular part point of view, for the side point of view, total up, because now the 1.57 from the right topmost circle, 1.57 from the bottom circle, and the 0 from the side. So this is what they summed, phi L, phi R and phi S. Phi S means phi side. So 1.57, 1.570, 3.14 is the total flux can be come out from that particular this cylinder Gaussian surface. Now this much flux can be, then what can be the how much charge it has, then it can able to generate this much flux. Then using the Gauss law, the the phi is equal to q by epsilon 0, then this is epsilon 0 is multiplied by phi, then you can able to find the q. The q is equal to epsilon 0 times phi. The phi is equal to 3.14 as we are finding earlier what we have 3.14, and then epsilon 0 is 8.8454 into 10 to the power minus 12 coulomb. Then the total charge you can able to find it with the calculator. This is what we have the example number 11 and 12. Thank you very much. Any kind of confusion if you have, then you can ask anytime, anywhere. Yes, I have to mention my number 9427553010. You can call me, you can WhatsApp me anytime, anywhere.